Good morning to Ananda present here. I am Dr. R. Gokuldas, Associate Professor, Department of Mechanical Engineering. Today, hand for the subject for Department of Mechatronics Engineering subject MF3391 Mechanics of Material. Okay, this is for B Mechatronics Engineering second year third semester. I am working in Sri Muthukumaran Institute of Technology, Chennai. Yeah. Now let us see this syllabus MF3391 Mechanics of Material. Okay. This is a 5 unit. Okay. Unit 1 stress and strain. Unit 2 analysis of stress and strain. Unit 3 shear force and bending moments. Unit 4 torsion and Unit 5 strain energy. Okay. This is the main syllabus for the mechanics of material. This also for this syllabus the same for the mechanical department for its 10th of material subject. Okay, these are both are the same content, same syllabus, but the heading only slightly changes. Okay, yeah. Let us see this one, unit one, stress and strain. This is the content of the unit one. The introduction, Hooke's law, calculations of stress in stake, stepper and taper section, composite section, stresses due to temperature change, shear stress and strain, lateral strain and Poisson ratio, generalized Hooke's law, Buck's modulus, relationship between elastic constant. Yeah. Now, what is the mechanics of material? The mechanics of material is a branch of mechanics, okay, that deals with the behavior of solid object subjected to various types of loading and stresses. Okay, it focuses on understanding how material deform and potentially fail the under applied force, okay, load or forces. Okay, playing the crucial role in the design and analysis of structure, machines, and components. Okay, let us see the some of the key components and key concept. Okay, this is stress and strain, material properties, deformation and failure. Okay, what is the stress and strain? The mechanical of materials and studies in internal forces like the stress and the deformation like the strain. Okay, that occur within the material when the subject to the external load. Okay, what is the internal force of stresses like that? The stresses like that, the load acting per area. Okay, the load acting for the area, the internal forces for the internal resistance acting for this object. Okay, the internal resistance acting for this load with area. Okay, the deformation like that, the strain is the object is after load conditions increasing the length. Okay, the original length to deformation length. Okay, changing length. Okay, this is the strain energy. Okay, next the mechanical property. It examines how the different material properties like elasticity, strength, ductility, influencing of materials response of stress and strain. Now also for the brittle material also. Okay, brittle natural, brittle like the glass and cast iron. This is a brittle material also. Okay, the material property also brittle natural also. Okay, the deformation of failure, like the field investigation, how material deform under loading, including the elastic deformation is a reversible one, and another plastic deformation is a permanent one. Okay, what is the elastic deformation and plastic deformation? The load after the tensile test. Okay, so go to the strength of material lab, the tensile machine, active for tensile machine, applying the load condition. The object fixing the vice. Okay, the object the load is gradually apply the load. Okay, gradually apply the load. Some stage return the load is released. The object is original position. Okay, this is elastic deformation. After that, the gradually apply the load, the maximum load are applied. Okay, the object is increased the maximum deformation. Okay, this region for the permanent deformation is a plastic region. So not once again not return the original shape. Okay, this is a plastic deformation. This is a permanent deformation. Okay, and how the ultimate fail like that the fracture and healed. Some of the application, worldwide application in the field in mechanics of materials, like that, the some of the importance for the structural engineering, mechanical engineering, aerospace engineering, material science. Okay, the structural engineering like the designing buildings, bridges, and other structure to withstand various loads and environmental conditions. Okay, the mechanical engineering design machining component systems and operate safely and efficiently under stresses. Okay, the aerospace engineering designing aircraft and spacecraft component that can withstand extreme stresses during the flight. Okay, material science develop the new material with tailored mechanical properties for specific application. What is the new material like the nowadays? The iron, the weight can the iron is some of the weight. Okay, replacing for the hybrid composite. Okay, hybrid composite is the composite like that natural composite and synthetic composite. Two composite. Okay, the synthetic composite like that glass, carbon, and Kevlar fibers. Okay, the three. Okay, the natural fiber is the maximum for the jute fiber, banana fiber. The natural worldwide, anyone the natural content is the natural fibers is applicable for the natural composites. Okay, this is the replacing for this iron. Okay, why? Because low weight and high strength ratio. Okay, less weight and high strength ratio. This is new material properties. Developing the new material properties. Okay, in essence, the mechanics of material provide the tools and knowledge to predict how a material will behave under loading, allowing engineering to design safe, reliable, and efficient structural and machines. Now, the stress and strain. The fundamental concept of material science and mechanical engineering that describe the how material under deforming loading here, yeah, clear breakdown of the two. Okay, first one the stress, second one the strain. Well, the stress is this one. The stress is denoted for the sigma, strain is denoted for the epsilon. Okay, the stress is this object is the stress object, this object is the strain object. Okay, what is the stress? It is known as when a deformation is stress. It is known as when a deformation force applied to a body. Okay, the restoring force and are developing the inside of the body. Okay, the resistance of the internal body. Okay, therefore the resisting force per unit area. Okay, per unit area by body is called stresses. Okay, the restoring forces is equal. Okay, equal and opposite. Okay, the force deformation force applied to the body. Okay, it can also be defined as the deformation force unit area of this body. Okay, this is a Newton theory law of action for this acting for this load. Okay, every action equal to opposite reaction. Okay, this concept was applying for the internal resistance acting for this stresses. Okay, next one the definition: the internal force unit area within per unit area within the material that resistant deformation. Like the stress formula, like the stress equal to force per area. The force, like the force equal to Newton unit. A convention for unit means force equal to Newton, area equal to mm. Okay, Newton per mm square. Okay, this is stress calculation for formula. Okay, another one the strain. This object the strain. What is the strain? The ratio of the changing in the configuration, like that shape, length, volume to the original configuration of this body is called the strain. The strain clear say it is amount of deformation experienced by the body in direction the force applied. Separate the original proportional of this body. Okay, like the definition like the deformation or displacement of material later relative to the original length. Okay, original. This example, this diagram for see that the opposite direction of the load is applied for a tensile machine. Okay, tensile machine length. This is the original length. The object is the original length. After load conditions, the deformation is occur. Okay, the gradual applied load, the deformation, the extension of the increase in the length. Okay, this increase in length is a elongation. This is a DL is for the elongation. Okay, the strain elongation divided by original length. The DL divided by L. Okay, this one the strain formula strain equal to changing length divided by original length. The changing length also mm. So the original length also mm is unit convention is cancelled. Okay, the strain is no unique calculations. Okay, next Hooke's law. The Hooke's law is a fundamental principle of mechanics of materials that describe the linear relations between the stress and strain in the elastic region of the material. Okay, the load is applied the starting stage. This load is applied for the this diagram. Okay, the load is applied the starting stage. The object, all molecules or element to reach the load conditions. Okay, load observed for the material domain. This domain. Okay, example for this material. This is a static state. Okay, not apply for the load. This is a static state. This is apply for the M1 mass. Apply the load W1 and mass to W. The gradually apply for the load conditions. Okay, static state. The static stage. Okay, applying the load. The inner surface. Suppose example the 1000 kilonewton, 1000 Newton. Apply the load means okay. The each element, the object, the each element. Okay, all molecules or cell. Okay, identify the cell. Okay, this is Newton equally element of maybe the 5000 element means okay. The 5000 element approach for the 1000 Newton. Okay, apply the 1000 Newton. The load is applied. Okay, after that the starting stage. After the gradually increase the load. After the staging, the starting stage of load apply condition. This is 0 to A condition. Okay, the withstand the load. Okay, the material after the loading condition, starting stage of the loading condition. Okay, this deform this 0 to A. This 0 to A is called Hooke's law. Okay, this is gradually apply the load. Okay, after the continuous load, the stress strain curve. After the explain for the stress strain curve, they used to understand for the material, what is the material property, what is the breaking stage of this stress strain curve. Okay, the hooks are with the starting stage of the observe the load condition for the material. Okay, the stress directly proportional strain. Stress directly strain, stress equal to Young's modulus in the strain. Young's modulus is equal to stress by strain. The Young's modulus formula stress by strain like that. A force per area divided by del L divided by L. Force by area means Newton per mm square. This one mm divided by mm cancel. The unit conversion Young's modulus unit Newton per mm square. Okay, another one. The mechanical properties of material, stress and strain. There are five fundamental types of loading: compression, tension, shear, torsion, bending. Okay, this is the example for this. After the testing this S1 material lab, go to the lab. This all testing conditions are applicable for our lab. Okay, this is a compression stress, the tension machine, tensile, and shear like the shear and bending like the flexure strength. Okay, torsion. Okay, these are five mechanical properties of strengthening for the Young's modulus calculated value. Okay, simple the stresses, the line diagram of the stresses, the direct stress and simple stress, indirect stress and combined stresses. Okay, direct stress or simple stress like the shear stress and normal stresses. Normal stress also tensile and compressive stress. Okay, the indirect stress like the torsion stress and bending stresses. Yeah, final slide. Hooke's law is applied to. The stress is strain curve. Okay. Before they explain the Hooke's law means this diagram for stress strain curve. Okay. These are the very good graph for this figure. Look at this figure. This is a very good for the live graph location. After the S1 lab go to the tensile machine acting for load condition, this graph is produced. Okay, the material properties are here. Okay, the material condition, what types of material, elastomia, ductile material, brittle natural, elastomia, what is the material condition for this graph is beautifully to graph for this software. Okay. Now, this is a oops, this is the stress. The x-axis is called the strain, y-axis to stresses. Okay, this 0 to A portion is a Hooke's law. Okay, this 0 to O condition, the elastic element is called the elastic region. After the deformation, not return the original shape. This is a plastic region. Okay, this is the proportional limit, the elastic limit of yield point, breaking stress. After finally breakdown for fracture point. Okay. What is the stress strain curves? Okay, look at this figure. The material stress strain curve gives it a stress strain relationship in a stresses strain curves. The stress and its corresponding the strain values is plotted. Okay, it's plotted when we study the solid and the mechanical properties. Information regarding their elastic proportional the most important. Okay, we can learn about this elastic proportional properties of the material by studying the stress strain relationship under the different load and in this material. Okay, what is the next one? The proportional limit. Okay, this is a proportional limit 0 to A. This is a proportional limit. It is a region of the stress strain curve that obey the Hooke's law. Okay, 0 to A is obey Hooke's law. In this limit, okay, the stress strain ratio gives us the proportionality constant known as the Young's modulus. The point OA is graphical representation of proportional limit. Okay. Next, the elastic limit. This one elastic limit, which is the material return its original position when the load acting on is completely removed. Okay, beyond the limit, the material doesn't return in the original position. This is a deformation, plastic deformation. Salt is appear in it. Okay. Next one, the yield point, which is the material. This yield point, which is material start the deformation plastically after the yield point is paused. Okay, permanent plastic deformation occur. There are the two yield point. Okay, one is upper yield point, one other is a lower yield point. Okay, next for the ultimate stress. Okay, ultimate strength like the B point and the x y graph. Okay, y axis the stress. This is this vertical. This line is the top edge is the ultimate stress point. Okay, it is a point that represents the maximum stresses that a material can endurance before the failure. Okay, beyond this point, the failure occur. What is a fracture and breaking point or fracture point? It's a point of stress strain curve at the which is the failures of the material take place. Okay, it's a finally the break of this material. That's all. Okay. Next slide. This is some of the examples of the stress strain curve. The example for how to draft. Okay, the different types of material testing the some lab tensile material testing strength. Okay, these properties are identified the some of the young smallest values, okay, calculated values, okay. Some the see the data book, standard data book, the see all values for see the some data book input values, okay. The first of the T, the young smallest is 10 power 11 Pascal. The Pascal unit like the Newton per meter square, okay. So 10 power 11 means divided by 10 power 6, okay, divided by 10 power 6, 10 power 5 Newton per mm square, okay, the unit calculation, okay. Next, steel, plastic, rubber, gel, and biological tissues. Okay, this is E power 10 power 9 is a plastic. E power 10 power 6 Pascal light rubber. E power 10 power 5 Pascal gel and biological tissues. Okay, this is stress and strain values. Okay, these are materials, some of the materials. So the high carbon is high strength, weight ratio, high strength. Okay, but not deformation. Okay, it's some of the Britain. Natural, okay, ductile property, okay, the cast iron, high strength, okay, aluminum, low strength, but deformation is more, okay, the changing of the deformation is more. You know very well the aluminum property is loading condition, deformation is increased, okay, this condition. The concrete are the same, okay, this is stress strain, the come this is example object. Thank you guys, thank you to see these videos. Thank you once again. The next class to discuss about the classification of materials, okay. Next class discuss this video the present for materials, okay. Already today topic the completed for uh, in mechanics of materials, okay. Thank you for watching. Thank you.